Welcome back, guys. I wanted to do a similarity theorem, but before we do similarity theorem, guys, there is this particular theorem. This is from grade 10. We learned it from grade 10 and grade 11. But so let's just do a revision of midpoint theorem because we're going to need this particular theorem. We don't have to prove it, but you have to apply it and know the reason of this particular theorem. This is very, very important. It's called the midpoint theorem. Now, so the midpoint theorem, it says that the line segment joining the midpoint of the two triangles is parallel to the third side of a triangle and half the length of the third side of this particular triangle. So basically, what does midpoint says? It says that whenever you are given the midpoint of a triangle, this particular line that is here between that bisect these two lines is parallel to what? Is parallel to this particular third side of a triangle, and it is also what? It is also half the length of the third side. So let me write it down so that you can be able to understand. So this, you're just going to do a conclusion that whenever we're given that AB is equals to BD, and we're also given that AC on the other side is equals to CE. This one, pay close attention to this particular theorem. They don't say that this side is equals to this side. No, they don't say that. They say this one is equals to this and this one is equals to this. So if we have this particular information, we can quickly conclude that BC is parallel to what? BC is parallel to DE. And we can also conclude that this particular BC, the length of BC, is equals to what? Is equals to half the length of DE. So we can also reverse this, guys. Now we can also say that the length of DE is equals to what? Is equals to 2 times the length of BC. So whenever you are given that these two sides are, this one is equal to this one and this one is equal to this one, then you can conclude that this side is parallel to this, and the length of this, if we are given that this one is 20, this one is going to be 40. Perfect. So this one is half this one is twice this one. Whenever you are given that these two are equal. So that's the midpoint theorem. So quickly, I wanted us to also look at the converse of this particular theorem, because the converse is the one that is a little bit tricky to other people. The converse of this one, I won't read this particular whole information, but I will tell you what they're trying to say here. Basically here, they say whenever you are given a triangle where you are given that one side, this one is equals to this one, and this line is parallel to this one. Look at the difference between these two. On this first one, on our midpoint theorem, we were given that these two are equal, and this one is not parallel. We are required to prove it, and as we concluded here, and also, so from here on, we are given what? That this side is equals to this side only, but we didn't given that this side is equals to this side, and we're also given that this one is parallel to this. So we can quickly conclude, if we are given this particular thing, this is the converse. This is not the midpoint, this is the converse. So if we are given that AB is equals to BC, and we're also given that BD is parallel to CE. So from this particular information, whenever we're given this particular information, then we can conclude that therefore this particular AD is parallel, is equals to what? Is equals to this particular DE. And we can also conclude that this particular side of CE is twice this particular side of BD. Or we can say that BD is what? Is half CE. Perfect. So what I want you to pay close attention to this part is the reasoning of this particular two theorem. So whenever you're given this particular kind of diagram where you're not given the two sides that are equal and you're also given the parallel lines between the triangles, then the reason for this one is you are going to say that this is the converse of what? Of midpoint theorem. Ne? So from this one, just going to say that it's a midpoint theorem. Ne? Midpoint theorem for reasoning for these two triangles. So I want you, again, I'm repeating this, I want you to pay close attention. These two are different. Ne? This one, you are given that two sides are equal. You are required to prove them what this side and this side, and also the parallels. This one are given the parallels. This is the converse of this particular theorem. So let's take a look at the examples so you can be able to understand how to apply this particular theorem.